Today, I'm going to talk about soil texture, and there's a lot of aspects about soil texture. It's hard to squeeze it all into a small segment like this, but I'm going to talk about some of the most important aspects of soil texture. The reason we're so interested, or we talk so much about soil texture is a physical property, and yet it determines so many things about soil: the quality of the soil, the ease of tilth or tilling of the soil. It even has some effect on some of the chemical properties, like the cation exchange capacity, or even to a certain extent how much lime or sulfur we would put out to adjust the pH, things that we'll talk about in another segment. So one of the things that when we talk about soil texture, it's always very hard for people to imagine, and really what texture really is size. And if you look at a texture triangle, which is kind of the standard way of discussing or expressing soil texture, there's actually a size for each of the three main soil particles: sand, silt, and clay. With clay being the smallest size particles and sand being the largest size particles. One analogy that people often use is the beach ball, frisbee, and dime analogy, and so I brought along some props here with me today to show you that. This is a beach ball, and the beach ball would be representative of the size particle that sand is, okay? So it's this big. This one's actually about 24 inches across. And then the frisbee is the next size class. This would be the silt, which would be obviously a little smaller than the beach ball, and I probably needed a slightly bigger beach ball to make this a perfect analogy. And then the third thing that we use in that analogy is the dime, and the dime representing the size particle of clay. And we talk about these different sizes because and use this analogy because it helps people to understand a little bit about things that are going on. For example, when we talk about drainage, the more scientific term, I guess, or the more accurate term would be permeability, the rate at which water moves through the soil. If you could imagine, if I took a bunch of beach balls and I filled them up a box or a room with beach balls, and we poured water over those beach balls, you could imagine that there would be another beach ball here, another one here. You'd imagine there'd be some pretty large air spaces between those beach balls, and you can imagine that water pouring down over the top would very easily kind of slide around those beach balls and make its way to the bottom of the room or the bottom of that box fairly rapidly, almost so rapidly that there would be very little water left in this upper area here where the roots or the plants are, very little water for the plants to get to. And then you can imagine if we filled the room full of the frisbee, you can imagine that there'd be again a whole room full of frisbees, and they'd be stacked all different ways and things like that. And if we poured water over the top, you could imagine that the water would have a little more of a pathway to follow. Maybe a little more water would stick to the surface or lodge in between where all these frisbees were stacked up, but still not a tremendous amount of water holding capacity. Then if we filled that room full of dimes, and we stacked them up, or didn't really stack them, just kind of meshed them all together and filled up that room full of dimes, something this small, you could imagine that tortuous path that water would have to follow around every dime, making its way all the way down through. You can imagine that some water would never make it to the bottom. Some would actually remain in those layers of dimes. In fact, if you've ever gotten coins that were wet on a countertop or on the surface of a swimming pool edge or something, that almost kind of sticks to it. Well, water would stick to those dimes much like water sticks to the clay. So we use that as an analogy as a way to maybe help people remember things like how water would move through the soil. Or just think about if you stacked up a room full of beach balls, if you went to one of those little parks or those little playgrounds at a fast food restaurant, and you went into those little chambers full of beach balls, you can imagine how easy it would be to kind of walk through those. Think of you being the plow moving through the soil. You could push through that pile of beach balls very easily. It'd be almost no problem at all. But if I filled that room full of dimes and you tried to wade through one of those little rooms or those mesh areas filled with dimes, you wouldn't be able to make your way through that. Again, you being maybe a plow or even water moving through that water. So it's a very common analogy that's used. It's not 100% accurate. It's just a way to talk about those different textures. Now, water movement and permeability is one key difference between these different soil textures. Another one is just how they feel. And I brought along just a few samples today, and there's a lot of different samples I could have gotten, but I got some from some of the fields right nearby here at the U Garden, because we have about 3 main soil types in this area. This first one is a clay, and I intentionally picked some that had some clods, and we're going to talk about clods in just a second. This would be kind of what most people think of as a red clay, and sometimes it has a lot of bad connotations. This is more of a sandy clay. You can feel it's kind of almost got a gritty feel to it. If you know, I don't know if I can get close enough with my mic to hear the gritty sound of it, but it's definitely got a little bit of a gritty feel to it. And this is not a real sandy soil. If I really want to get a sandy soil, I'd go closer to the coast where you have a lot more sand content in the soil. And then this soil here is more of a, actually it's kind of a sandy clay loam, and it just has a, it almost feels more like, almost like a powder. It's not nearly as gritty. And it's not as sticky, obviously, as this clay is. It's already made these little chunks here. So it's somewhere kind of in between these two. And each of these soils has its positives and negatives. It's not to say that the clay is all bad, or the sandy soil is terrible, or the loamy soil is good or bad. Certainly we know that a loamy soil is probably the kind of the best of a lot of the different characteristics of the soils, things like drainage, nutrient holding capacity, ability to till the soil or the soil tilth. But we can even take this chunky clay, and under better circumstances, we could take a clay soil like this and we could improve it or amend it by additions of compost or organic matter, by working it at the proper time. This soil was actually worked when it was wet, and that's why I brought this sample in. This is what happens when you work a clay soil when it's too wet. You get clods, C-L-O-D-S. I don't think that's really a scientific term, but it's literally like little clay bricks in a round pelletized form. And this is a reason right here why people don't like clay soils, is because when you work them when they're wet, when you till them or shovel them when they're wet, and you don't break them up thoroughly at that time, if they sit on the surface of the soil for very long in the sun, they're going to dry and turn into these clods. And this kind of messes with the soil structure, and it actually takes sometimes years for this to work out. So this is definitely a negative of clay soils. Not all clay soil does this. Not all clay soil looks like this. I kind of brought in the worst case example of clay soil when it's been worked too wet. Of course, the sandy soil, as I mentioned in the beach ball analogy, the sandy soil's negative is that when it rains, water moves right through it, which is great. It's got good drainage. It's got a lot of air spaces and pore spaces that are filled with air, but it doesn't hold on to water nearly as well. It almost drains too quickly. And the loamy soil, again, is probably kind of the perfect mix or the blend of that sand, silt, and clay. Now, I haven't talked much about the soil texture triangle, but the soil texture triangle is literally just a Venn diagram that actually has some real information embedded in it. The Venn diagram would be just a triangle like this with sand at one point, silt at another, and clay at the other point. And the idea being that if you have a pure clay soil, it would be all the way over at one point of the triangle, and if you had a pure sandy soil, it would be all the way at the other point of a triangle. A pure sandy soil would be like what you would find at the beach. A pure clay might be if you dig down into one of these clay mines, like where they mine bentonite in Georgia. If you dug down the bottom of that pit, you would get a very hard, sticky, and even then it probably is still not a pure clay. And then silt would be at the other point of the triangle. And the idea of looking at this triangle is that depending on the percentages of each of those different components, the sand, silt, and clay, you would kind of land in different parts of that triangle. And if you were to get closer to the center of that triangle, you would have kind of that loamy type soil, which is very similar to what I showed you in this example right here. You would have a soil that would be like this. This is actually what is called a sandy clay loam. And the point being that you never are going to have a soil that is any one of those three things. It's going to always have some components of each of those things. It's never going to be all sand, all silt, and all clay. And rarely is it going to land right in the center of that triangle at the perfect loam. This is actually a little on the left-hand side of the triangle, because it still has a fair amount of sand and clay in it. It just looks a little different. You see slight differences in the color, and definitely has some slight differences in the feel. So I set up this little just a little demonstration, and this is not a scientific analysis or a comparison of different soil textures, and I'm going to actually set this back on top of here because each of these soils goes with the soil that I've put in the jar. This is just kind of a simple method if you want to kind of get a sense of what kind of soil you have. Again, please, if you end up with a clay type soil, don't feel like you've got to remove it or change it or all that much. In fact, it's very, very hard to change the texture of a soil. Sometimes people will add sand to a clay soil thinking they're going to make it drain better. If you're going to do that, if you're really trying to push the texture from a clay soil to a sandy type soil, you're talking about adding feet of sand or of a different texture. And in general, we don't recommend that. What we recommend is properly amending a clay soil, working a clay soil at the right time. You know, one of the actual virtues of a clay soil, and again, these clods don't really give it a very good name, but one of the virtues is it actually holds moisture better than the sandy soil does. So it's not that all clay soils are bad, okay? So what I've done today is I've actually filled these mason jars up about halfway up with soil from these 3 different fields where I took these samples from, and I filled the rest with water. And what I'm going to do is I'm going to take these have already been setting, so I'm going to take this first one and I'm going to shake it up for each of the samples. And if you do that, if you fill your jar about halfway with soil and the other half with water and you shake them up, in the first 30 seconds or so, whatever lands on the bottom, pretty much, the bottom layer, that's going to be the sand, okay? And if you wait about 30 minutes, whatever lands on top of that is going to be primarily the silt particles. And this is because these particles of different sizes will settle down at different rates, okay? So we can go back and we can look at this first one that I did, which was the sandy clay loam, and you can see, again, you see some slight settling beginning here, and this first amount of settling is the percent sand. And then if we come back in 30 minutes, we'll see that the next layer is the percent silt, and then we come back later and we'll see what the percent clay is. And you can see in all of these samples that I had shook up yesterday before when I first set this up, you can see there is still some clay, fine little clay particles that are still in suspension. And this is one of our concerns with runoff and erosion, is that whenever we have water that leaves the land, it often takes soil with it, particularly those clay particles. And we're always worried about those clay particles getting in our rivers and streams, and this is a very good demonstration of that. You can see that even 24 hours later, in each of these jars, there's still a little bit of cloudiness, and that cloudiness is those really fine clay particles that are still in suspension. So again, this is not a scientific means to determine what kind of soil you have. You could, if you wanted to be really precise about it, you could actually measure the percentage. You could measure the total height of your soil. You could measure the percentage that settled out to be sand, the percentage that settled out to be silt, and the percentage that settled out to be clay. And then you could actually take those percentages and go back to that texture triangle, and you could look and follow around the triangle for each of those percentages. Of course, they all have to add up to 100. And wherever you came out to on that triangle would be the type of soil that you had. If you want a really precise measurement, the best thing to do would be to send a sample off to one of the soil test labs in your state. Here in Georgia, the soil test lab is here in Athens, and for about $10 or $15, they'll do a more thorough analysis, and they'll actually tell you exactly what the texture is. But this is for the homeowner, this is not a bad way to get a sense of kind of what the different percentages are. Again, it's not going to tell you exactly how to manage your soil or exactly what to do. It just gives you a little sense about what the different amounts of things you have. And you can see on some of these, you can see there's actually the debris kind of sits here. When you first shake it up, often this layer right here is not just debris. Some of that is actually some of the organic matter. And you can see there's a very fine layer. Remember, organic matter, even in a good day or a good soil, only amounts to 5 or 10% of the content of the soil. So it's going to be a very fine layer, and that organic matter is going to stay in suspension for a real long time because it too is very fine particled. And I'm looking now that these have kind of settled out, and I can see that I'm already getting some pretty distinct layers, each one slightly different. The colors of them, of course, are a little bit different based on, in this case, a little more clay with this one over here. It's got a little more iron content in it. This appears to be the sand component of this. Again, all of these have a pretty high, sand component to them. What appears to be mostly different is the percent clay and the percent silt is probably the biggest difference between these 3 different samples.